Alright, so this is about to be section 2.6. I'm properly caffeinated this morning, so hopefully I'm not hyper and I don't go too fast during this lecture. So this section is on different number bases, and I can't even imagine why, like, as a student, you'd even have a concept of what a different number base is or was. Our base that we work in is base 10 because we have 10 distinct, we'll call them digits or numbers, the numbers 1 through 9, and then again 0. Back in the early 1980s, kind of the dawn of computers being kind of mass-produced and available for a reasonable price, computers used to work in a binary base, which is base 2. And in base 2, the only digits that are allowed are 0 and 1. And just using 0 and 1, we are able to write any number that we can in base 10. It just looks a heck of a lot different. The reason at the beginning of computers 0 and 1 were the only numbers allowed is because, I don't know how computers work now, but computers would either sense an electrical impulse or not sense an electrical impulse. And if you sense electrical impulse, I imagine it's a 1 and it's a 0 if you don't sense an electrical impulse. And so base 2 was used in early computers. Most computers now work in what we call a hexadecimal base, which is base 16. And in base 16, you have 16 distinct digits. In base 2, you have 2 digits. In base 10, you have 10 digits. And in base 16, you have all the digits that we have in base 10. And then you have a digit that represents 10. A represents 10. B represents 11. C represents 12. D represents 13. E represents 14, and F represents 15. I have had minimal experience working with base 16. The only time I've ever had to work with base 16 is picking colors. Like the color that I picked on my webpage, that blue, when there's a six-digit number in base 16 that says what that color of blue is. When I was making the Venn diagrams in chapter 1, when I wanted to fill the Venn diagrams up with colors, the color name would be something in base 16. And if I wanted a region to be white, in base 16, I would type this color, 6 consecutive Fs, which is essentially 6 consecutive 15s. That would represent white on the computer program that I was using to do the Venn diagrams. So computers work in base 16 probably exclusively now, and so it's important. Other bases do exist, and so it's nice to be aware of them, I guess, especially in the computer world. On the next few pages, it talks a little bit about some other bases and when and where they were used. It turns out that bases 2 through 10 are probably the easier bases to work with. Once we start getting beyond 10, bases 11 through 16, where we have to make up digits, like A is a 10, B is 11, C is 12, it gets a little bit harder, and we won't work with those bases, although maybe if you want to get some experience with base 16, I can teach you how to work in it, but ultimately, I guess if you ever had to work in base 16, you'd be taught that in the class that you're working with that base in. So this next page I thought was kind of interesting, just some stuff that I snagged off the internet. It says, most cultures work in base 10. We've got 10 fingers and 10 toes. It makes sense to do that. And then I thought this was kind of interesting. I don't know if that's Yuki Indians of California used base 8 because they counted the spaces between their fingers and toes rather than between the toes themselves. Babylonians used base 60, Mayans used a mix of base 20 and 18, and then some base 20 terminology has crept into the English language. The French say whatever that word, I've never took French, for 71, which means 3 20s and 1 11. So in base 20, you'd have 20 as the kind of like our 10. For what that's worth. So different bases have been used. Apparently in the Gettysburg Address, 7 years ago, 4 scores would be 4 20s, and then 1 7 means 87. So different bases have been used at different times. Mostly, most everybody works in base 10. That's just because it's just what we're used to working in. And except in the world of computing where base 16 is kind of prevalent. So in this section, all we're going to need to do is go backwards and forwards. If I give you a number in base 10 and tell you to convert it to another base, we'll do that. If I give you a number in a base other than 10, I'll have you convert it to base 10. So this is kind of similar to the Roman numeral section where we went from common numbers to Roman numerals and then Roman numerals to common numbers. And similarly to the Roman numeral section, one direction is easier than the other. In the Roman numeral section, I did the easy way second. Here I'm going to do the easy way first. But the easy way isn't as easy as the easy part of the Roman numerals. There's more junk on here about just different number bases. You can read that if you care to read that. I think it's kind of interesting. If this one was printed in color, I used a base 16 number that gave me this sort of purple color, but it's hardly purple anymore because they afford me a color printer. So if I'm working in another base, then I'm only allowed certain digits. And this sheet just shows you, like in other bases, what different numbers are. So like if I wanted to write the number 8 in different bases, well, in base 10, 8 is just 8. But in base 2, I'm only allowed the numbers 1 and 0. Apparently in base 2, 8 is 1 0 0 0. And generally, if I'm writing a number in a base other than 10, I subscript the base. So I'd read this as 1 0 0 0 base 2 is equal to 8 base 10. Apparently in base 3, where I'm only allowed the numbers 0, 1, and 2, 10 is 2 2, or 8 is 22 base 3 essentially. So in different number bases, the numbers that we're used to in base 10 will look radically different because we're only allowed to use certain digits. In base 2, I'm only allowed to use the digits 0 and 1. In base 2, I'm only allowed to use the digits 0, 1, and 2. Yet all three of these numbers are equivalent to 8 base 10. They look completely different. So our goal is going to be able to take a number in base 10 and transform it to other bases, and take a number in another base and change it to base 10. Being aware of what numbers we're allowed to use. In base 10, we're allowed to use the digits 0 through 9, base 2, 0 and 1, base 3, 0, 1 and 2, base 4, 0, 1, 2 and 3, and kind of so forth. So, in order to do well, converting back and forth between bases, we need to know powers. And on this sheet, there's a bunch of powers that I'll refer to a lot in this section. So when we're doing this section, you might want to have this at your fingertips. You're probably going to need to know most of the powers of 2, at least up to 128, probably higher. The powers of 3, at least up to 3 to the 5th, which is 243. I think 3 to the 6th is 729. We might actually need that. So I need to have at my fingertips all the powers of any base that I might be interested in. And since we're not going bigger than base 10, I didn't put any powers of numbers bigger than 10. And for whatever reason, I skipped the 7. I must not have a problem that has base 7. Probably when I created this little table, it was just powers that I knew in my head. And then once I got beyond what I knew in my head, or what would fit on this sheet, I stopped writing them. So I'm going to keep this handy. So first example, the easy direction. So 1403 base 5, I want to convert it to base 10. So I have no idea what 1403 base 5 is equal to. Apparently, it's equal to 228 base 10, because that's what the sheet says, and I don't think I have a mistake here. So 1403 base 5 is equal to 228 base 10. And when the base is 10, you generally don't write the subscripted number, but if the base of a number is anything other than 10, you generally write that. So 1403 base 5 is equal to 228. How did I get that? It's not terribly hard. First step is to take the number and write it backwards. So the number without the base is 1403. I wrote it backwards as 3041. Just exactly wrote the number backwards. So step 1 to convert from any base other than 10 to base 10 is to write the number backwards. So I had a 3, a 0, a 4, and a 1 is the number written backwards. Then, next to each number, the 3, the 0, and the 4, and the 1, I'm going to put a times sign followed by a 5 with an exponent. So the first number, 3, that I got from writing it backwards, I'll put a times sign and then a 5. And then I'm going to start with the exponent of 0, and each time I'm going to go up by 1. So I'll get 3 times 5 to the 0, 0 times 5 to the 1, 4 times 5 to the second, and 1 times 5 to the third. I also need plus signs between each one of these. So plus, plus, plus. That's how I'm going to do the computation to figure out that 1403 base 5 is equal to 228. Now this is purely a calculator problem. This 0 piece I don't need to enter on my calculator because 0 times anything is equal to 0. So when I do my calculator, I'm not going to enter that part. And I could enter it exactly, or I could do some work in my head. I'm just going to enter it exactly. So I'm going to go 3 times 5 up arrow 0 plus 4 times 5 up arrow 2 plus 1 times 5 up arrow 3. So that's just entering it exactly how it looks, and I get 228, and I'm done. So going that direction is not particularly hard. Write the number backwards. Next to each number, I put a times sign, and then the base with an exponent, starting at 0 and going up until I'm out of numbers to put the base next to, and then put plus signs and then use my calculator. Base 2 is always the icky one because the numbers get really long. So if I wanted to convert 101110 base 2 to base 10, I start off by writing the number backwards. So I'm going to write 0, that 0, and then 3 ones, then that 0, then that 1. So I took the number, wrote it backwards, 011101. Next to each of the numbers, I put a times sign and a 2 and an exponent with each of the 2's. The first exponent is 0. The second exponent is 1. The third exponent is 2. The fourth exponent is 3. Fifth exponent is 4. And the last exponent is 5. So that's what it's going to equal to once I get the plus signs between. So plus, 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 plus. Use my calculator. I'm not going to do the zeros on my calculator because those are equal to 0. So I'm going to enter the non-zero part on my calculator. Clear this out and go 1 times 2 up arrow 1 plus 1 times 2 up arrow 2 plus 1 times 2 up arrow 3 plus 1 times 2 up arrow 5, and I get 46. Simple as that. So going backwards is going from a base other than 10 to base 10 is really not that hard. It's kind of the easy way in the Roman numerals. You can do a bunch of work by hand, and down here I showed you how to get it without a calculator, but I mean it's kind of pointless. I'd much rather do this on my calculator than do it by hand. Alright, so Now we'll do the homework questions. I have the answers for all my even ones written on here because this is the second time I'm recording this video. For one reason, I knew I made a mistake, and for the second reason, the second half of this, it wasn't a very smooth lecture, and I kind of found my zone as I got to the end of it, and decided I would do it over. So, first step for number 2, you should be doing number 1, is to write the number backwards, and then put a 5 followed a times sign, then a 5, and make exponents on the 5s. For you, you're going to have a 4 because your base is 4. Start with 0 and work your way up until you're out of numbers, and put plus signs between. So I hope to get 213 base 5 is equal to 58 base 10, and I won't write the base 10. So I'm going to go 3 times 5 up arrow 0 plus 1 times 5 up arrow 1 plus 2 times 5 up arrow 2, and I get 58. So I did it perfectly, and I did it without being very clever because I could have done this by hand. This is 3 times 1, which is 3, plus 1 times 5, which is 5, plus 2 times 25, which is 50, and then 3 plus 5 plus 50 is 58. It's pointless in some sense, I think, doing it by hand, because I'm more likely to make mistakes trying to just break it down by hand. If this was a test question and you had this much right, and then you made some mistake and didn't get the right answer, you're not going to lose a lot of points for making a calculator mistake. Alright, so 3 and 4. So for 4, I'm going to take my number and write it backwards. So I'm writing a 1 first and a 3 second, just like you'll do for 6. Now I'm going to tack on a times and a power of 4, starting with 0 and working my way up. So 1 times 4 up arrow 0 plus 3 times 4 up arrow 1, and I get 13. So I'm going to get 31 base 4 equals 13 base 10. So I'll just go through these quickly. Our numbers are different for 5 and 6. My number, they call that a palindrome when it's the same forwards and backwards. I think that's what it is. I'm going to write 1, 1, 0, 0, 1, 1 times 2 to the 0 times 2 to the 1 times 2 squared times 2 cubed, didn't leave myself a lot of room, times 2 to the 4th times 2 to the 5th, plus, 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 plus. Don't have to do the zeros on my calculator, they're going to equal 0. So, I enter what's there, hopefully it's more or less readable. So, 1 times 2 up arrow 0 plus 1 times 2 up arrow 1 plus, skip those 2, 1 times 2 up arrow 4 plus 1 times 2 up arrow 5, and I get 51. So 1, 1, 0, 0, 1, 1 base 2 is 51 base 10. I got all these answers by just doing a search on the internet. I said base converter, and I found a web page where you could just enter the number and its base, and it would tell you what it is in base 10. It would tell you what it is in every base. So I didn't do any of that work by myself, but it made me more accurate today probably. So 7 and 8, essentially the same numbers, except it's going to be a little bit different. I'm going to go 4 times, 3 times, 2 times, and 1 times, and then 6 to the 0, 6 to the 1, 6 squared, 6 cubed, plus signs between. That's all that it is. Apparently that's supposed to be 310. Hopefully it is. So 4 times 6 up arrow 0 plus 3 times 6 up arrow 1 plus 2 times 6 up arrow 2 plus 1 times 6 up arrow 3, and I get 310. Beautiful. So for your answer, you can just write what it's equal to, or you can write the problem and then the answer next to it. So just about 6 more of these. Quite honestly, this is probably already enough of these for you to know how to do it. This is the easy direction. So we can try 9 and 10. I'm going to write 2, 1, and 7 backwards times 8 with an exponent of 0 times 8 with an exponent of 1 times 8 with an exponent of 2, plus signs between. Supposed to get 458 if I did that properly. So 2 times 8 up arrow 0 plus 1 times 8 up arrow 1 plus 7 times 8 up arrow 2. I get that exactly. So for my answer, it's 458. Your answer has to be different. It has all different numbers. So I can start to do these pretty efficiently. So start writing it backwards for number 12. 5 times 7 to the 0 plus 1 times 7 to the first plus 2 times 7 squared plus 3 times 7 cubed. Apparently that's 1139. Make sure 5 times 7 up arrow 0 plus 1 times 7 up arrow 1 plus 2 times 7 up arrow 2 plus 3 times 7 up arrow 3, and I get 1139. 4 more of these, and then we'll go backwards. Backwards isn't hard, it's much more tedious though. Yours should look just like mine, other than instead of having 3s, you're going to have 2s. So I did 1, 0, 1, 1, 1, wrote it backwards, put times 3 to a power next to each, and then I won't do that one on my calculator. It's not necessary. It's equal to 0. So 1 times 3 up arrow 0 plus 1 times 3 up arrow 2 plus 1 times 3 up arrow 3 plus 1 times 3 up arrow 4 equals 118. And that's exactly what it's supposed to equal. 3 more of these. So 15 and 16, I'll do 16. 4 times 6 to the 0 plus 0 times 6 to the first plus 1 times 6 squared plus 2 times 6 cubed. Wrote the number 4012 backwards, multiplied by powers of 6s. I won't do that one on my calculator. It's not necessary. So 4 times 6 up arrow 0 plus 1 times 6 up arrow 2 plus 2 times 6 up arrow 3, and I get 472, which is perfect. Caffeine is helping my accuracy today. Nicely, double zeros in here makes less on my calculator. So backwards, 1 times, 0 times, 0 times, and 2 times. And then 3 to the 0, 3 to the 1, 3 to the second, 3 cubed, plus signs between. Don't worry about the zeros on my calculator. So I'm going to do 1 times 3 up arrow 0 plus 2 times 3 up arrow 2. I'll get 19. Hey, that's not good. Oh, really? 1 times 3 to the 0. 0, 0, 2 times 3 squared. I don't see a mistake on this, so I'm wondering. This concerns me. Let me double check it. 1 times 3 to the 0, which is 1 times 1, which is 1. 0 times 3 to the 1, 0 times 3 squared. 2 times 3 cubed, which is 2 times 27. This is going to be 1 plus 54, which is 55. So it's so nice to have the answer ahead of time, so I didn't make a stupid mistake like that. Let me recalibrate it. I forgot to make that exponent higher. So it should be 1 times 3 up arrow 0 plus 2 times 3 up arrow cubed. It is 55. So that's, it's just hard to be perfect, I guess, and harder for me than most. So, I mean, I just never will hammer you for a lot of points if you make a silly mistake like that. Understanding that it's probably, if I can tell I know what you're doing and you just make a mistake like that, you're not going to get hammered. So, last backwards one. So I write 1, 3, 0, and 2, and then times 4 to the 0, times 4 to the 1, times 4 squared, times 4 cubed, plus, plus, plus. Don't do that one. 1 times 4 up arrow 0 plus 3 times 4 up arrow 1 plus 2 times 4 up arrow 3. I get 141. Perfect. So now for the harder direction. For the harder direction, that's going from base 10 to another base other than 10. That's a little bit tricky, and I do them with a table. So next problem I want to do is go from 1742 base 10 to base 5. And I'm going to do that by making a table, and let me make sure. I'm going to make a table to do this. And the top of my table, I'm going to start off with words, and I'll shrink the words over time. Original number or remainder. My first column is going to start off with a 1742, which is the original number. Because I'm converting to base 5, I'm going to need to have powers of 5, and a lot of them. And I'm going to do some subtracting, and then I'm going to have the number for my answer. So to convert from 1742 base 10 to base 5, I need to know powers of 5. And very specifically, I need to know every power of 5 that's less than 1742. If I look at my powers of 5, I have 5 to the 0, which is 1, 5 to the 1, which is 5, 5 squared, which is 25, 5 to the 4th, which is 625, and then 5 to the 5th, which is 3125. That's too big. So I'm going to have 1, 2, 3, 4, 5 columns of numbers, taking each one of my powers of 5 and writing it in the power of 5, going backwards. So I'm going to go 625, 125, 25, 5, and 1 in the row that I marked power of 5. I'm not going to do 3125 because it's bigger than 1742. So for my powers of 5, I'm going to have a 625, a 125, a 25, a 5, and a 1. So I have it all sketched out what I need. So I took the original number and put it at the top of the first column. I went to my powers of 5 and I found every power of 5 that was less than that number, and I wrote them backwards. So that's the biggest power of 5 that's less than 1742. Wrote it right underneath the 1742, and then I made a column for the 125, the 25, the 5, and the 1. Every power of 5 that's less than 1742. Almost done. Now it's just subtracting. So first thing I'm going to do is take the number at the top of the column and start subtracting the power of 5 until I get less than that power of 5. So I'm going to subtract 1742 minus 625 one time until I get a number until I get a number less than 625. So I subtracted it once. This number is bigger than 625, so I need to subtract it again. And if I just hit minus 625, it'll do that subtraction for me. Once Once I subtract and get smaller than that power of 5, I'm done subtracting. This becomes the number for the next column, which I call my remainder. So if I subtracted 625 again, I would get a negative number. I don't want to produce any negative numbers, so I'm going to call that the remainder. And I was able to subtract 625 twice. That's going to be the first number in my answer. Done with the first column, I'm going to move on to the second column and do exactly the same thing. And that exactly the same thing is to subtract. I'm going to go 492, which is the remainder from that step, subtract the next power of 5, which is 125. Now it's a calculator problem that I'm going to do all on my calculator. So now I'm going to go clear 492 minus 125 equals 367. Now I'm going to go minus 125 again and get 242. Still can do it, so I'll go minus 125 again. And once this number is less than what you're subtracting, you stop, because the next subtraction would give me a negative. So I'm done with the 125 column, and I need to do two things. I need to carry the remainder over to the top, and I need to find out a number for my bottom row. The number for my bottom row is going to be the number of times I got to subtract that power of 5, which is 3. Now I'm going to subtract again. So I'm going to go 117, the remainder, minus the next power of 5. Better leave myself a little more room because I need 4 of these. So I'm going to go 117 minus 25, and I'll get 92. Minus 25 equals 67. Minus 25 equals 42. Minus 25 equals 17. Now I'm less than 25, so I'm going to stop. And then when I get done with the column, because 17 minus 25 would be negative, I need two numbers to fill in. The number for the bottom, which is the number of times I got to subtract 25, which is 4, and then I bring my remainder up. Now I can probably finish this up without my calculator, but that's dangerous, so I won't. So I'm going to go clear 17 minus 5 is 12. 12 minus 5 is 7. 7 minus 5 is 2. Can't subtract 5 again or I'd get a negative. So I'm going to have 1, 2, 3 for my bottom. Bring the 2 up. Now I'll start subtracting. 2 minus 1 is 1. 1 minus 1 is 0. Once I get to 0, I can't subtract anymore. I've used my last power of 5, and I was able to do 2. So my original problem, 1742 base 10, is equal to 23432 base 5. That's all the rest of the section is going to be, is constructing a table, subtracting, carrying your remainder over, and subtracting again. Sometimes we'll not be able to subtract. We're going to get zeros in some of these rows because I won't be able to subtract. And I don't know, this is about as hard as it gets, really, other than the zeros that we haven't got to yet. All right, so let me make sure I have the right answer. So 23432 base 5, which is perfect. All right, so another example, and then we'll get into the homework. So my table is just a little bit different than that I have written up, and I like this table a little bit better. So on my top of my table is going to be the original number or the remainder. It starts off with the original number and then it goes to the remainder. actually says remainder. And then I need power of 4. And then some room to subtract. And then number for my answer. So the original number is 441, and I'm changing to base 6. So I should say power of 6 here. All those 4's got me flustered apparently. So my original number is 441. Now I need to find powers of 6 that I need. So I go to my chart and I look at my powers of 6. 6 to the 0 is 1, 6 to the 1 is 6, 6 squared is 36, 6 cubed is 216, 6 to the 4th is 1296, which is too big. So the first power of 6 I'm going to write down is 216, and then I'm going to write 36, 6, and 1. I'm not going to write 1296 because it's bigger than 441. So my power of 6 is going to be 216, 36, 6, and 1. Those are all the powers of 6 that are less than 441. I didn't include 1296, it was too big. I did 216, 36, 6, and 1. Now it's just subtracting. First subtraction is going to be 441 minus 216. So I start off with 441 minus 216, and I get 225. Well, I can subtract 216 again because I have a remainder that's bigger than 216, so I'll subtract it again. And that takes me down to 9. So I was able to subtract twice, so I'm going to put 2 down here for the 2 times that I'm going to subtract. Carry my remainder up. Here's where I'm going to get a 0, because what I'd like to do is go 9 minus 36, but that's going to produce a negative. And if the subtracting produces a negative, you can't do that subtracting. So I'm not allowed to subtract 9, the remainder, minus 36, the next power of 6. Because doing that subtraction even once is going to give me a negative. This is when I get a 0. When the remainder is less than what you need to subtract, you get a 0. And you just carry the remainder over to the next column. And now I'm going to do the subtraction. This subtraction I can do. 9 minus 6 is 3, but 3 minus 6 would give me a negative. I can't subtract it again, so this becomes my remainder. And the one time I was able to subtract 6 becomes the number at the bottom of the column. Last column, I'm going to subtract my remainder minus the power of 6. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. I'm at 0. I've used all the powers of 6. I'm done. There's 1, 2, 3. So for my answer, 441 base 10 equals to 2013 base 6. I don't have to write the base 10. I don't really need to write the original problem. If I just wrote 2013 base 6, it would be perfect. And if you look at my work, I got 2013 base 6. The order of these top two, the order of the top rows, I switched. I thought, just because I think it turned out easier when I switched them. It made it easier to see, so I switched them, and I'll go in and change these in my write-up just so to be consistent with myself. All right, so now to the homework. So we're both working with base 5, so we're going to start off our tables. We're going to have either the remainder or original number, because it starts off with the original number. For me, I'm going to put a 56 at the top of that column. For you, you're going to put a 43. And underneath it, we're both going to put a power of 5. And if I look at my powers of 5, 1, 5, 25. 125 is too big. So we're only going to need to put in 25, 5, and 1 for our powers of 5. Because 125 is too big, we can't subtract it. So I'm going to have 3 columns. One that's going to have a 25 for a power of 5, one for a 5, and one for a 1. Yours will be the same 3 powers of 5. So we're going to have a 25, a 5, and a 1. The only difference from your problem 21 and my problem 22 is you should have a 43 where I have my 56. But your powers of 5 should be the same. And now we're going to start subtracting. And I'll be ready down here for my answer. First subtracting I'm going to do is 56 minus 25. 56 minus 25 is 31. I'll go 31 minus 25 is 6. I'm going to get a 2 down here because I was able to subtract twice the 25. Carry my remainder over. Now start subtracting. 6 minus 5 is 1. Can't subtract again. Bring my remainder up. On the bottom, write a 1 for the one time that I could subtract. Last subtraction, 1 minus 1 is 0. I've used up all my powers of 5. I'm down to 0. I'm done almost. Just need to write a 1 down here. And now I'm going to write my answer. My answer is going to be 211 base 5. Which is supposed to be beautiful. And you can check your answer as well. They're available at the end of this section. So now it's just another, 10 problems, I guess, to do. Is that how many? 22, 24, 26, 28, 30, 32, 34, 36, 38. Yeah, 10 problems to do. So that's just what we did. Move on to the next page. We're working with base 3. So I think I can fit it right here. So I'm going to start off with the original number or the remainder. I'm going to start off with 315. You're going to start off with 213. Now I need to know my powers of 3. I'm going to have one more power of 3 than you. I'm going to have one more column than you because my number's bigger. I get an extra column that you're not going to get. So the powers of 3 that I need go all the way up to 243. Yours is only going to go up to 81. So I'm going to have all the way up to 243. My first column is going to be 243, and then 81, 27, 9, 3, and 1. You're just going to go 81, 27, 9, 3, and 1 because 243 is too big for you to subtract. So you get an easier problem. So I'm going to have a 243, an 81, and you're just going to start with an 81, a 27, a 9, a 3, and a 1. And what am I going to subtract to start? I'm going to start off by subtracting 315 minus 243. 315 minus 243 equals 72. So I'm only able to subtract once, because if I subtract again I'd get a negative. I'm going to carry my 72 over. I can't go 72 minus 81 because it would give me a negative. So I'm going to write a 0 down there, because 72 minus 81 is negative. Bring my 72 over and start subtracting 27. So 72 minus 27 is 45. 45 minus 27 is 18. Done subtracting because, again, if I subtract again, I would get negative. So I'm going to get a 2 for the bottom of this column, bring my remainder of 18 up, start subtracting again. 18 minus 9 is 9. 9 minus 9 is 0. I'm at a 0, so I can't subtract anymore. The bottom of this column is going to get a 2 for the 2 times I could subtract. I bring my remainder over, and 0, I can't subtract anymore because I would get a negative. So I can't subtract the 3, so I write 0 for the number of times I could subtract the 3, bring my remainder over, and I can't subtract the 1 because 0 minus 1 would give me a negative. So I write a 0 for the number of times I could subtract it. Had the answer right here, it's going to be 102200 base 3. So the thing that can be tricky is figuring out the zeros. And my number had to have 1, 2, 3, 4, 5, 6 numbers in it before the base 3. So there's 1, 2, 3, 4, 5, 6. And every time the number up here is smaller than that number, you're going to get a 0 because you can't subtract and get a negative. So I had 3 cases where the top number was lower than the power, and that's when I pick up my zeros. All right. So base 2s are the bad bases because they get really long. I have 1, 2, 3, 4, 5, 6 again. Yours is actually going to have 7 in it. You're going to have to go all the way to 64. So I'm going to start off with I'm just going to start writing number right here rather than writing original number or remainder. And then I'm going to write power. I better emphasize it's of 2. And this is my subtract. And then my answer. There's a way to get the answers by division. I've had bad failures when I try to teach by division. So now I need to get all the powers of 2 that are up to 53. And for me, I'm only going to go up to 32. You're going to have to go up to 64. So my first power of 2 that I'm going to write is 32. I'm going to go 32, 16, 8, 4, 2, and 1. You're going to go 64, 32, 16, 8, 4, 2, and 1. So you're going to get 1 extra column from me because your number's bigger. So I'm going to write 32, 16, 8, 4, 2, and 1. And again, you're going to have another column that starts, you're going to have 64, 32, 16, 8, 4, 2, and 1. And now I subtract. So 53 minus 32. Clear this out. 53 minus 32 is 31. Really? Did it wrong. 53 minus 32 is 21. Can't subtract again. Write my 1 down. Bring my 21 up. And go 21 minus 16, which is going to be 5. Now 5 is less than 16, so I'm done subtracting. I write a 1 on the bottom, carry my remainder over. 5 minus 8 is negative, so I can't do that. I'm not allowed to get a negative, so I get a 0 there. Carry over my 5. 5 minus 4 is 1. Done subtracting. Write a 1 down low, carry my 1 over. I can't go 1 minus 2 because it's negative, so I get a 0 here. Bring my remainder over. 1 minus 1 is 0. I'm at 0. I've used all my powers. I'm done after I write the 1 down here. And my answer is going to be 1, 1, 0, 1, 0, 1, base 2. You're going to have 1 extra digit in your answer. All right. Ours are going to look the same here. So we're going to go number or you can write original number, remainder if you care to, power of 2, room to subtract, and then the number for my answer. Just like the last time, I only need to go up to 32. So I'm going to have a 32, a 16, an 8, a 4, a 2, and a 1, because those are all the powers of 2. 32, 16, 8, 4, 2, and 1. 64 was too big. I didn't need to go to 64 because 64 was bigger than my number. Now I'm going to get a lot of zeros here. There's 3 zeros in my answer. So first subtraction, 41 minus 32, I believe is 9. 9 minus 32 would be negative. I'm done subtracting 32. On the bottom I get a 1. I bring my 9 over. 16 is bigger than 9, so I can't subtract it. I put an X there, call this a 0. Bring my 9 over. 9 minus 8 is 1. Only able to subtract 1 time. Carry my remainder over. Can't go 1 minus 4 because 4 is too big, so I get a 0 there. Carry the 1 over. 1 minus 2 is still negative. I can't do that subtraction. Put an X there. Make this a 0. Bring my remainder over. 1 minus 1 is 0. Used up all my powers of 2 and got to 0. I'm done after I put the 1 down here. So this is going to be 1, 0, 1, 0, 0, 1, base 2. So it's very repetitive, and it's not horribly hard once you get just this part set up, and once you get the initial table set up, it's just subtracting. Base 5, you have to go to base 4. For your table, the numbers that you're going to need in base 4 is all the way up to 256. You're going to need a 256, a 64, a 16, a 4, and a 1 for the powers of 4 that you're subtracting. You didn't need to go to that one. And for me, I'm going to need to go up to just 25. I just need a 25, 5, and 1. So I start off with my original number and remainder column. I'm going to need my power of 5. Some room to subtract. A lot of room because 1 times I need to subtract 4 times. And my answer. Start off with my 72, and I need a column for a 25, a column for a 5, and a column for a 1. Again, you're going to have 5 columns, 256, 64, 16, 4, and 1, for the 5 powers of 4 that are too small. So first subtraction, 72 minus 25. Time for my calculator because I'll probably blow that. So 72 minus 25 is 47. 47 minus 25 is 22. Write a 2 down here for the 2 times I could subtract. Carry my remainder over. Subtract. 22 minus 5, 17. 17 minus 5 is 12. 12 minus 5 is 7. 7 minus 5 is 2. Done subtracting 5s. I was able to subtract 1, 2, 3, 4 times. Bring my remainder of 2 over. Now go 2 minus 1 is 1. 1 minus 1 is 0. Used up all my powers of 5 and I'm down to 0. Write down the last number on the bottom, which is 2. My answer is going to be 242 base 5. Just 5 more to go. And it's probably already enough homework. I mean, if you can do it, you can do it. So I don't know that seeing more examples is going to make it better. For your base 6, you're going to need 36, 6, and 1 for your powers of 6. So you need 36, 6, and 1. I need 4,096, 512, 64, 8, and 1 for my powers of 8. So I want my original number, 5120. Then I need my power of 8. And for me, it's going to be, what I said, 4,096, 512, 64, 8, and 1. Again, you just have to have the powers at your fingertips. That's why I keep exploiting this table. So I took all those 4,096, 512, 64, 8, and 1. From yours, I just took the 36, 6, and 1 from the powers of 6. Now I'm going to subtract. And I don't have to do more than 2, so, and then I get my answer. So first, 5120 minus 4,096. 1,024. Done with that number, write a 1 down, bring the 1,024 up, and subtract. 1,024 minus 512 is 512, and 512 minus 512 is 0. I'm down to 0. I'm not allowed to subtract anymore, but I certainly don't have an answer yet. So beneath the 512, I'm going to write the 2 for the 2 times that I could subtract. Bring my remainder up. I can't do 0 minus 64 because that would give me a negative. Write a 0 for that column because I wasn't able to subtract. Bring my remainder over. 0 minus 8 would give me a negative. I can't do that subtracting. Write a 0 at the bottom of that column because I wasn't able to subtract. Carry my remainder over. 0 minus 1 would give me a negative. I can't subtract that, so I get a 0 there as well. So my answer has a boatload of zeros in it, but my answer had to have 5 different spots in it because there were 5 powers of 8 that were less than 5120. So my answer is going to be 1, 2, 0, 0, 0, base 8. So once the number on the top row is bigger than the power, you get a 0 for that column. But you need a number for every column. So there are 5 powers of 6. My answer of 8. My answers need to have 5 digits in it. Oh. To base 3, 3120. Oh gosh. 729. I need 3 to the 7th. 2187. I don't think that's going to show up on there. So for you and your problem, you're doing base 5, and you're going to go up to 625. So you're going to have 625, 125, 25, 5, and 1 for your column. So you need a 625, 125, 25, 5, and 1. I'm going to need 2187, 729, and a boatload of them. I'm really not happy about this one, but it is what it is. So I'm really going to have to write small. Hopefully it's still readable. My initial number is 3120. And then I'm going to do 3 to the power. And I'm going to have 2187. 729, 243, 81, 27, 9, 3, and 1. So yeah, I had up to 243. Then I multiplied 243 by 3 and got 729. and then 729 by 3 and got 2187. So I had to get really far. It was really unfortunate. But now I'm ready to subtract. First subtraction, and then my answer. So subtract. So 3120 minus 2187 equals 933. Done subtracting that. One on the bottom for the one time I could subtract. Bring my remainder up. Now I'm going to do 933 minus 729. I get 284. Can't subtract again. Write a 1 down here for the one time I could subtract. I'm worried because my answer's not matching up what I think it should be, so let me make sure I haven't messed up anywheres. I could have entered this wrong on a computer and got just a wrong answer, but all of a sudden it's not working. So I'm going to do 243 times 3 is 729 times 3 is 2187. 3120 minus 2187 equals 933. Perfect. 933 minus 729 equals 204. I don't know what I had entered before, but this should be 204. Let me do that again. 933 minus 729 equals 204. And that's one time. Now I bring the 204 up. I can't subtract 204 minus 243. That would give me a negative. Put a 0 at the bottom. Bring the 204 over and start subtracting 81. So 204 minus 81 is 123. Minus 81 again is 42. Done subtracting the 81. Put a 2 up here. Bring my 42 over. Now I'm going to go 42 minus 27 and get 15. That's as much as I could subtract that. I get a 1 down. Bring my 15 up. 15 minus 9 is 6. Done subtracting that. Get a 1 on the bottom for the one time I could subtract. Bring my remainder over. 6 minus 3 is 3. 3 minus 3 is 0. Done subtracting that. 2 on the bottom. Bring my remainder up. Can't subtract that. Put a big X and a 0. So this is going to be 11021120 base 3. And it matches up what I got on using the website that does it for me. 3 more problems. For your problem, you're going to need to go 64, 16, 4, and 1. For my problem, I'm going to need the powers of 2, and I'm going to need 64, 32, 16, 8, 4, 2, and 1. Base 2 is the worst. So let's start off with my original number, which is 123, and then I need a power of 2. I'm going to need 64, 32, 16, 8, 4, 2, and 1. And now I'm going to subtract. So 123 minus 64 is 59. Can't subtract it again. So for my answer, I'm going to get a 1 for the first number. Carry my remainder up and subtract. 59 minus 32. It's 27. Bring my 1 down because I can't subtract anymore. Bring my remainder up. Now go 27 minus 16 is 11. Can't subtract it anymore. Put my 1 on the bottom. Bring my 11 up. Then do 11 minus 8, which is 3. Can't subtract anymore. Get another 1. Bring my 3 up. 3 minus 4 is negative. Can't subtract that. Put a 0 down there. Carry my remainder over. 3 minus 2 is 1. Done subtracting there. Put a 1 up there. Bring my remainder over. 1 minus 1 is 0. Was able to do that 1 time. So my answer should be 1, 2, 3, 4 1s, a 0, and 2 1 base 2. 2 more. Base 3 and a big number. For your, oh gosh, you're going to need up to 256. So you're going to go 256, 128, 64, 32, 16, 8, 4, 2, and 1. So it's a monster. For me, I'm going to need 729, 243, 81, 27, 9, 3, and 1. So do my original number. Power of 3. See, I'm starting to get lazy, and it's fine. You don't have to have these things worded out so nicely. And then subtract, and then my answer. I'm going to start off writing my 914, make a 729, a 243, an 81, a 27, a 9, a 3, and a 1. First subtraction, 914 minus 729. Equals to 185. I get a 1 there. I bring the 185 up. Can't subtract that because that would give me a negative. Put a 0 at the bottom. Carry my 185 over. Do 185 minus 81. Get 104. Minus 81 again is 23. Done subtracting that. Was able to subtract it twice, so I get a 2 at the bottom. Bring my 23 over. 23 minus 27 would be a negative. Can't do that, so put an X there. Get a 0. Bring my remainder of 23 over. 23 minus 9 is 14. 14 minus 9 is 5. Was able to subtract 2 times, so I get a 2 here. Bring my 5 up. 5 minus 3 is 2. Can't subtract again. 1 subtraction on the bottom. Bring my 2 over. 2 minus 1 is 1. 1 minus 1 is 0. Was able to do it 2 times, so I get 1, 0, 2, 0, 2, 1, 2, base 3. Last problem. Oh, that was the last problem. That's even better. Oh, awesome. I thought I had one more to do, but we don't. So hopefully that was adequate. I feel like I explained it at least where it's understandable, and that's kind of usually my goal. And I don't think I made a mistake because I had the answers out ahead of time.